Hey, ProbStats kids, this is Dr. Callahan with week 13, Monday. Go ahead and answer the following 3 questions. I hope you guys had a good weekend with the last 2 days on virtual learning. So go ahead and pause the video and answer the warm-up questions. All right, go ahead and check your answers for question number 3. And here's a breakdown for today's lesson. You guys should have the brand new guided notes. If you do not have that yet, you can go ahead and copy this down on a separate piece of paper, or you can even print it out yourself. Just go to the Google Doc and you'll be able to find the guided notes for this unit. It is Unit 4, Chapter 5, so 5.1. Today we're going to talk about interpreting creating diagrams of normal probability distribution. We're going to find the area under the standard curve. I'm going to go over our examples on examples 5, 7, and 8. All right, so with that said, turn over to page 1, which is the introduction to normal distribution. Go ahead and read the objectives right here, highlighted in yellow. All right, so what is normal? Human behavior and characteristics often follow a normal pattern where a large number of people have similar behavior in the center, which is right here, and that's the mean. A smaller number of people have unusual behavior or called outliers at the end. Okay, what is a numeric distribution? This is really important. It is a continuous probability distribution for random variable x. The most important continuous probability distribution in statistic is normal distribution. The graph of a normal distribution is called a normal curve. And here are some properties of that. The mean, median, mode are the same value. The normal curve is a bell-shaped and it's very symmetrical about the mean, which is the center. The total area under the curve is equal to 1 or 100%. The normal curve approaches but never really touches the x-axis as it extends further away from the mean. So here are some of the other normal distribution properties. It is between the mean minus a standard deviation and the mean plus a standard deviation. This is generally when you have +1, 2, 3 standard deviation and -1, 2, 3 standard deviation. The graph curves downward and the graph then curves upward to the left of u minus standard deviation and then to the right of u minus standard deviation, plus standard deviation. So this is the area where it's a plus a standard deviation, left side is a minus standard deviation. All right, so the point at which the curve changes from curving upward to downward is called an inflection point. So like, for example, if this is my curve upward to downward, inflection point is right there. A normal standard deviation can have any mean and any positive standard deviation. The mean gives a location of the line of symmetry, which is right here. If I were to fold this over, you'll see that they're exactly the same size, kind of like your hands, as in putting your hands together in a reflection. The standard deviation is described as a spread of the data. So if you take a look at the 3 graphs below, your inflection points are right here. This spread obviously is very wide, it's flatter. This spread is very narrow, so it's skinnier. And this one here, if you take a look at it, is just skewed to the left because most of the data are moved over to the left. Okay, so let's take a look at this. Which curve has a larger mean? A or B? A larger mean, I would say, is A because the mean of A is right here at 15, whereas the mean of B is right here at 12. Which curve has a larger standard deviation? Standard deviation often means the spread. So which graph look like it's stretched out more? It will be B because it's flatter and it is stretched out further. Go ahead and fill out the following, and then we'll go over some more examples. All right, so let's go ahead and take a look at this page right here. Example 4. For each of the normal curve, estimate the value of the z-score and the area in the shaded region. So look at the blue part where it's shaded. You know right here where the mean is. This area is 50%. Then at this point right here, I would guess that it's going to be about 35%. So then my z-score is just 50 plus 35, which is 85%, which leaves the remaining unshaded area as 15%. Which kind of goes to the second question right here, which is that shaded area right there. So your z-score here is just going to be 100 minus 50 minus 35, which is approximately 15%. Then let's take a look at the next question here. Now, you know that at the mean, which is going to be at the mean, this is going to be your first -1 standard deviation. And then here you will have +1 standard deviation. And then perhaps over here at +2 standard deviation. So what percentage would that account for? Well, you know that the first standard deviation to the mean is 35%, or I'm sorry, 34%. The other positive standard deviation from the mean is a positive, but still at 34%. At 2 standard deviation, the percentage goes down to 13.5. So if I were to add everything together, 34 plus 34 plus 13.5, I would say that your z-score is about 85.5, 81.5%. All right, now let's take a look at this. Now, if you're in my class, I will be passing this out. This is a Z table, and it actually gives you a correct percentage. Like if your Z score, let's say, is 1.75, then you just simply go down here, and I'll tell you that, okay, it is at 95.99% for a positive, and then of course, this side here is for the negative. But let's go and use this chart to answer the following question. And if you are in a hybrid day on Monday, make sure you grab this piece of paper from me as well. All right, so let's take a look at example number 6. For example number 6, actually, you know what? I'm just gonna go ahead and skip over to example number 7. Okay, example number 7. It says find the area under the normal curve to the right of the z-score of negative 0.99. So given the fact that this is a negative 0.99, we need to figure out what percent is that going to be. So let's go ahead and refer to the table. Because it is going to be a negative 0.99, it is going to be right here. 99 right there. So what number is that going to be? It looked like 0.611, or 16.11%. So it looks like your z-score is 16.99%. Okay, so what that means is that you're gonna have to go ahead and represent the 16.99%. So it's probably gonna be like, if this right here is at 50 and this is at 34, 13.5, I would say that 16.11 is going to be about like right here. So let's say that this z-score is going to be at 16.99%, which is going to be for this area right here. So if you're like, well, if that's the case, then what about the rest of the area of this bell curve in orange that's shaded? Well, if you're interested in finding that, you simply take your 100%, because the entire bell curve is 100, and you will want to go ahead and subtract the 100 from minus 16.99%. So the rest of the orange area is 83.89%. All right, let's take a look at example 8. For example 8, find the area under the standard deviation of the normal curve between, keyword is between, negative 0.99, and we knew that that was 16.99%, which was like right there, and positive 2.61. So let's take a look at this. Positive 2.61 is going to be right here, and that's 99.55%. So 99.55%. So then at the 99.55%, this is your z-score, 2.61. You know that everything on the left side of this, which is this area right here, that area is 16.99%. Everything on the right side of this, so including this entire area all the way over here, so including that green area and the entire orange area, because remember, when you're looking at the percentage, this green area is from here to here, okay? Now your orange area is from the very end all the way over to here. And that orange area is going to be 99.55%. So if you want to find the area between that, and that area between will result in this yellow area right there, you will have to subtract the two percentages from each other. So this yellow area is going to be 99.55 minus 16.99, which is going to give you 83.44%. And that is your answer. All right, you guys, I hope that kind of makes a little bit more sense of how this works. So now what I want you guys to do is take a look at this piece of paper that's being passed out. I would like you guys to go ahead and if you're on a private day, you can go ahead and just do these questions on a separate piece of paper and turn it in. That's totally fine. I would like you to find the area and sketch between 0 and 2, 0 and 3, negative 3 and 3, 0 and 1.7, etc. So do exactly what we just did in class and make sure you sketch the little graph. And then when you are done, your exit ticket is when you keep your teachers on your toes, you are keeping her ready for anything. Share below what your teacher could do to help you learn better on the material. All right, you guys, I hope you have a wonderful day. And as always, stay safe and healthy. And I will see you guys next time. Take care.